So I want to go back to our essential question. How are elements related to stars? When I say elements, I mean everything. Everything is made up of elements. Another word for this is matter. So in order to explain this, we have to talk about the star life cycle. Okay. So stars are formed in a stellar nebula. Oops. Stellar nebula goes to creates stars. You can think of that as a nursery. So that starts with what's known as a protostar, which means before. And that goes to a brown dwarf. This is a dim star. And that goes to what we know and love, which is a main sequence star, which is our sun, or like our sun. When the sun starts to die, or any star, they actually begin to expand and get bigger and become a red giant. When a red giant begins to consume all of its energy, it becomes a white dwarf. Still emitting light, but it's dim again. And then eventually that can become, or will become, a black dwarf. Essentially all of its energy is gone. Now I'm saying no light, but actually I don't know if it's no light, but it's essentially impossible to see. And then, if the star had enough mass, now to be clear, our star does not have enough mass for that. You get a supernova. Now, a supernova is a huge explosion. Sorry, I'm doing this with a stylus, and it does not like my palm. Huge explosion. If that supernova, to continue on with the life cycle, has certain properties, it can become a neutron star, which means that it's so massive, there was so much mass, that only the neutrons in an atom are emitting this energy. And there's lots of really cool information online. We don't have to explain too much of it, but it's made up of these neutrons. And not all stars become this, but if it was massive enough and the explosion was big enough, it can become a black hole. Don't like that. And black holes are their gravity is so strong that they can actually absorb light. And they emit radiation. That's how we're able to identify them. It is thought that black holes can start a galaxy. For instance, there is a supermassive black hole. I'll go ahead and write that. Supermassive black hole at the center of our galaxy. So, how does this relate again to our essential question about elements? Well, elements are formed in stars. So let's talk about how that happens. You have, let's use my shape tool here. Well, actually, to get this started, let's talk about how an atom is formed. So, oh my goodness. So let's talk about helium. Helium is the second element on our periodic table. Second, meaning that it has 2 protons. So blue will be our protons. Let me write that. Proton. Let's make red our neutron. no charge. Here, we'll go back to blue. Proton has a positive charge. And let's make green our electron. Okay. Now, I'm going to write an electron. Let's see if I can get this right. Oh my gosh. There. All right, so here's our atom, proton, neutron, electron. The mass is determined by this part here, which is what we call the nucleus. Nucleus has our protons and our neutrons. Electrons are part of the electron cloud. Now, it's called a cloud because these are three-dimensional objects. So this here is 2D. We're on a flat surface here. It's a 2D representation. But an atom operates kind of like a sphere. So it has 3 dimensions. So that's why we call it the cloud. Because the electrons are kind of floating around in there as a cloud and in 3 dimensions. They don't just circle that like that. So these atoms here, when you have a hydrogen, so hydrogen has 1 proton, 1 neutron, and one electron. Oh my goodness. And in the center of the sun, you have so much gravity that these elements, let me get you another one here. Get pushed together. Okay, so remember this one was helium. This one is hydrogen. Okay. And with all of that gravity in the sun, it pushes hydrogen nuclei so close together that they actually fuse. Aptly named fusion. When fusion occurs, again, let's get our colors here. We have now 1, 2 in our nucleus, protons or neutrons and protons. When fusion occurs, it releases a whole bunch of energy. So now the sun has gone from hydrogen here to helium. Now this doesn't happen on Earth. There aren't any forces strong enough to create fusion on Earth. If we could have a fusion reactor, it would be very clean energy. It's the same kind of energy we get from the sun. So inside the sun, we go from hydrogen to helium. Well, what if a helium and a hydrogen are formed or pressed together? So we're in the core of the sun. We have hydrogen plus helium. Fusion occurs. More energy is released. And then we get lithium. Okay. And then if we get, let's just continue on, helium and helium in the sun, or a star, not necessarily our sun. So now we have 4 protons. 4 protons is represented. So you get, again, you'd get it energy. And then you would also get beryllium. So then this process just continues on and on until you get to iron. So a star can create all of the elements up to iron. Iron is, I think it's 16 protons. Okay. But after that, if you're you're aware of the periodic table a little bit here, there are quite a few other elements. So after iron, for instance, we have copper. We have selenium. We have krypton. So how do we get this other stuff? Where do the rest come from? Well, if you remember that life cycle of the star, we had that huge explosion we call the supernova. You have huge, massive amounts of energy being released from that. And in this process, we can get elements heavier than iron. Okay. So supernova occurs, the energy is released, but then so are these other elements. So if you think back to whenever the first time you've heard of it, I don't know curriculum-wise when you've heard of it, you have the Big Bang. The Big Bang. And the Big Bang, you have quarks and whatnot. Quarks go to turn into protons, neutrons, and then we're floating around here. Oops. So we're floating. So we have all these elements. Let's go ahead and add some color. We can make that a little bit bigger. Okay, so this is our early universe. We got our protons and neutrons and such here. Just kind of all spread out from a singular point. Oh my goodness. Where we had that Big Bang occur. So the universe is expanding here, okay? But as it's expanding, we have these little spots that start to form. Here, let me make that a different color. Let's go ahead and do this. We have these little spots, these pockets of something we call gravity forming. Gravity takes all of this energy, or these protons and neutrons and such, and starts to make stars. And then we have that whole star life cycle starting. And here in this early universe, we start to get stars, and then those stars collect into galaxies. So, like our galaxy is a spiral arm galaxy. And those are filled with stars. And then all of these stars, not only in our galaxy, but throughout the entire universe, are collecting these little bits of protons, neutrons, and other elements that have been forming since the beginning of the universe. And those elements start to congregate in little pockets that we call a solar system. So, for instance, our solar system started out as a cloud of dust. Oh my goodness, it's so hard to write with this thing. Our solar system. So at first, our solar system is just this. Here, let's use purple, make that a little bigger. It's just this cloud of dust. When I say dust, I mean all of the elements that created our solar system are here at this point. Elements, just to be clear. Well, gravity starts to happen again. I mean, gravity is always happening. And then those particles start to tighten up into what's known as an accretionary disk. Is it disk or disk? I don't know. Let's go with this one. And gravity continues. And then our sun starts to form. And around that sun we still have little bits of dust. Okay, so here we have a sun, no planets. Sun, or what's known as a protostar. Protostar sun, no planets. So no planets are here. The sun isn't really producing enough energy or gravity, but it's continuing to suck up additional fuel. Now that fuel is hydrogen. Hydrogen fuel. And as this is happening, little pockets of gravity, so here we have our sun again, are starting to form around it, around the sun. And we start to get planets. One, two, three, four, five, 6, 7, 8. Okay. So we have planets forming in the early solar system. And those planets are taking the leftover elements. And as these form, you get 1, 2. So we have Mercury, Venus, Earth, Mars. Mercury, Venus, Earth, Mars are terrestrial planets made up of mostly iron and nickel and some silicon. And then you have your, let's do gas giants, the different color. So you have Jupiter, which is our largest planet, Saturn, Neptune, and Uranus. We call these the gas giants. These are made up mostly of hydrogen. So if you notice, we have hydrogen here and we have hydrogen here. You're probably noticing a pattern. Hydrogen is the most abundant element. Abundant meaning it has a lot of. Oh my gosh, this is so hard to write with. Most abundant element. That's terrible. Now, there are a few other parts here to the solar system, and just to complete our model here, our sun does eventually become a main sequence star. Let's make it a little bigger. Main sequence. The main part of its life. And when that happens, it pushes away any atmosphere that these planets could have had. with solar wind. Oh my goodness, come on. So it wipes out the atmosphere of these types of planets. So no life is going to happen for a while. So as things are orbiting the sun here, we finally have a stable solar system. But this is far beyond 4.6 billion years ago. Well, not far, but so let's go ahead and write 4.7 billion years. That's how long this took. Well, we know that it had to have occurred at least 4.6 billion years ago because that's how old planet Earth is. So I'm just saying 4.7 because that's older than the Earth. And then the rest is history after that. All right, I might have to stop here because it seems like this app is starting to mess up. I would like to go here. I guess I can erase it. I don't want to erase it.